Give me 1 second here to kick this off. All right, we are live on YouTube as well. Thanks everybody for joining the Programmability and Automation Meetup group. The topic this week is unlocking network telemetry. And then, someone mute here real quick. Yeah, so thanks everybody for joining. Daniel Hertzberg is going to present on unlocking network telemetry from a housekeeping standpoint. You can ask questions in the chat. We'll monitor those as they pop up, as well as if there's anything, you can come off of mute and ask questions that way as well. This is being obviously recorded and live streamed, so if anybody that you know didn't make it or you have to leave, you'll have access to the recording, the presentation, and any relevant links after the fact as well. So if it's your first time joining us, thank you. This is something that we try to do every 4 to 6 weeks from a content standpoint to get a variety of topics out, and looking forward to this one this week. And with that, I will turn it over to you, Daniel.
Cool, thanks, Nick. Appreciate it. And thanks for having me talk about this. But plenty of talks on telemetry, OpenConfig, and Go, and so on and so forth. So always awesome to talk about these things. I'm really in depth to and enjoy technology. But this session will be about mostly streaming telemetry. My Twitter handles there if anyone wants to kind of take a look at most things I do. It's telemetry, Kubernetes, Golang based. I work for Arista, so we have a place where we typically kind of a markdown page. We call it open management. It's the bottom right-hand corner. These slides will be distributed. So if you're ever curious about getting started, mostly taking a look at telemetry, OpenConfig, and so on and so forth, like it's a pretty good link for you. And also any of the code I'm going to go through within this demo will all be within my own personal GitHub repo under Telemetry Meetup 2024. Just a little about me, just for break the ice here. I'm a TME at Arista Networks. I've been here for almost 8 years, and I've seen many different observability and telemetry platforms. I do a lot with it. So there's a lot of like a love-hate relationship with OpenConfig. Mostly in this talk, you'll find that you're not just going to flip the switch, get rid of SNMP on day one, and that's it. There are some things and issues and so on and so forth, but there's some pluses and some negatives that surround gNMI as a whole. And I'll try to cover most of them, but I field many different calls, many different sessions a week from just customers on this exact topic. Agenda-wise, how do we get here? It's mainly going to be, I'll say bashing SNMP. I'll try to hold my thoughts and objectives towards that, but it's really mainly because of SNMP. We'll go into gRPC, and gRPC itself is going to be, I could even have a talk on that because it's such a broad topic. We'll talk about what Yang is. We'll talk about more or less about gNMI. That'll be really where the crux of this will be. And then we'll go on with some demos as well. So just to kick it off with a couple memes, like live the meme life here. This talk will be about deprecating SNMP. Like, I don't want to beat a dead horse on SNMP, but we're going to talk about why it's bad. I think most of us as network engineers, even if you are like kind of a infrastructure person, obviously the idea behind pull-based things are bad. I don't think anyone's going to disagree with that. Do miss the show Arrow. Wife and I, we watch it all the time, but the meme is awesome. On the right, I asked Dolly too to create what observability on networks would look like, and this is what it created me, which is like kind of funny. Person doing a picture of a couple of networks. Kind of looks like a futuristic Grafana type of deal on network switches in the bottom left-hand corner. But mainly we're going to talk about what it takes to remove SNMP and how you would do it. Obviously, SNMP, there are some bad things to it, there are many bad things to it, but I think the problems are pretty obvious. It's a pull-based method. The data structure's all over the place. Getting bulk data is extremely difficult. It's a UDP design, so if it gets there, it gets there. There's no such thing as timestamps. There's no concepts of that. And scaling out the infrastructure is pretty hard. The other thing with the data structure is just kind of the way the MIBs and voids are set up. So upper right-hand corner, 1, 3, 6, 1, 2, 1, 15, 3, 3, 1. That's a MIB or an OID of basic BGP, like BGP neighborship. You can see at the bottom, and as you walk the MIB tree, kind of what that looks like for the IP addresses of the neighbors. And it's kind of hard to work with. I just think that most of us put this on our network because most of our tooling just kind of like surrounds it. I mean, that's kind of is what it is. The RFC itself is from 1990. So for SNMP, and really nothing has changed very much. Like we've got like V3 authentication, V2 came out with some of the bulk data, but it's not enough to monitor like your modern cutting edge 400 gig networks. It's just not the greatest thing. Also, polling data, I think most of us know this, but on the top, you can see the switch state. So interface goes down, let's say in the middle of that. Those horizontal lines resemble, let's say every 5 seconds, every 10 seconds. So within that interval, let's say 3 seconds, 4 seconds, an interface goes down, comes right back up. Hold state, it's going to say everything's 200 okay, like you're happy. It all looks good to you. The stream state, however, any change delta that happens, interface happens to go down, it comes back up, the change delta gets streamed off to a telemetry collector, which I'll cover here in a little bit. But the ideology is any change state. So not a constant poll of every 5 seconds, 10 seconds, or 15 seconds, but it'll actually be change deltas that are streamed. And it could be either a push or a pull method, and we'll kind of get into that. The foundation for it is this. Like if you were to look at like the whole 1,000 foot view picture of kind of like what streaming telemetry is, this is the ideology. You have your switches at the bottom. They communicate to the telemetry collector over gRPC. That gRPC service is gNMI. But either way, the whole ideology is something changes on the device. There's a change happens, and it gets streamed to the collector. That could be either push or it could be pull based. Everything happens over gRPC. If you're unfamiliar with gRPC, great. We're going to go into it here in a little bit. But the ideology, just so everyone's clear, is we're removing the SNMP portion of a pull every so often. So you're not pulling, you're not SNMP walking. The whole ideology is that intrinsically to the device, it's sending its data to a telemetry collector as it happens. So change deltas with things like fan speed, change deltas with things like routes, change deltas with things like interfaces going up and down. Very common things, but as they happen and as they progress, automatically assign. So first thing we get to is gRPC transport. So with SNMP, you have UDP, and UDP is so-so, depending on the application. But gRPC as a whole, the whole idea is that you take a basic service, you wrap it in this thing called a protobuf. All right, thanks, WebEx. The whole idea behind gRPC is that you define a service. Within that service, you specifically put in different methods, and those methods are called upon. Well, we have a slide here next coming up to it. But the big thing about gRPC is that it supports streaming. Like within the protocol itself, you could stream with it. That's like the best, in my opinion, it's the best part about it. It's language agnostic, which is really cool. And the other thing is that you auto generate these fields based off of the protobuf. It'll make sense here in a second, but all streaming telemetry technologies, well, mostly most streaming technologies on a switch are going to be gRPC. What does it mean streaming? We'll get to that here in a second. You'll understand here in a moment. So here's an example of a protobuf. So think of gRPC as a service. You have RESTful services, for example, and gRPC is also an RPC. So the whole idea behind an RPC is that it's a remote procedure call. It's something you call in code, whether it's a method or a function, and that makes it feel like it's within or next to the device. Now, the way you create that service is going to be through a proto. So you can see in the upper left-hand corner, this is called demo.proto, very creative. We can see on line 5, you basically kind of create your manifest for the protobuf. So we're calling the service a user service. On line 6, we call the RPC create. We pass in create request. And create request is on line 17. It's all strongly typed, which is really cool. So you can see like the first name, last name, age. First name, last name being a string, and the age being an integer, and it returns user reply. What you do with this, because obviously this is just a text file, it does nothing for you, but there's a thing called proto-C. So over towards the right, proto-C will basically take any protobuf file and compile it to the language of your liking. So for example, if you are into Go, it'll compile the demo.protobuf.go file. If you're into Python, it'll create a Python library for you. You just basically import it in code. And the interesting part about that is that you kind of have a protobuf file that exposes the service, and then from any language that supports protos, you can then create and talk to it through it. So bottom right-hand corner, you have a service that runs the user server, for example, gRPC service. And you have like in Ruby and Java, which sometimes you'll see it associated called a stub. And a stub is basically a way of saying it's a client. You're probably wondering why I'm telling you all this, because gNMI is simply just a gRPC service. Like, that's really it. Now, to answer someone's question about streaming, what exactly that means, at the very bottom, I'll explain that here in a second. But the gNMI protobuf, I have it in, once you get the slides, you can kind of go to it, like it's on the OpenConfig website, and we'll get to what OpenConfig is on their GitHub. But it'll tell you all about the actual service. So for example, the capabilities method. So if you want to ask a switch, for example, what Yang models do you have? What version are they? You call capabilities. A GET request is a simple, just like a one-time, you can compare it to like HTTP GET, one-time GET request, and you get a response. Set is a little bit out of the context of this talk, because set really allows you to configure a device, which is pretty cool stuff. I've blogged about it. There's some things like PyYangBind and YGOT, which are really good. I think people should check out, but it's kind of not related to streaming. To answer the question that came in, RPC subscribe. So at the very bottom, you can see RPC subscribe. And when you call that, there's a keyword called stream, and it returns subscribe response. So effectively on the client side, we'll see in a slide next, on the client side, the client will stream subscribe request and it'll return subscribe response as it happens. And it's obviously I couldn't fit everything on the one slide here, but within the subscribe request, it asks for a path and that sort of thing. But just the key takeaway is gRPC allows streaming. That's really was really nice about gRPC versus something like UDP. All right, or I'm sorry, like REST, for example, use HTTP1. All right, gRPC, stream. I think there might be some protocompiler for C++. Obviously, given my lack of outer age, I haven't had to work with C. I've been very fortunate. Like memory stuff, I've had to work with things like Rust, but I've never had to work with C or things that require memory. So maybe I'm fortunate and unfortunate. I don't know. I'm not sure if there's a protocompiler for C, but the most common one's Go, just because it works well with gRPC. All right. Anyway, so gRPC works a couple different fashions. Unidirectional, so obviously that's going to be a request and a response. Server-side streaming is pretty interesting because it's more or less the client asks for something and the server responds with a stream. Client-side streaming is more of an upload thing, so the client can stream very quickly and just get a single response. Bidirectional streaming is what gNMI does when you subscribe to it. So effectively, we'll get into it, but the client will ask the server for specific paths, and those paths may change, it may not change, but it's a continuous stream of data, and it's in both directions. So it's like a fire hose of data back and forth. I like to meme it up a little bit. So how it started, how it's going. Off to the left is SNMP. SNMP is a little bit, like I said, hard to work with. To get these MIBs and these like OI trees. This looks a little simplified, but most of us have had to do a whole bunch of SNMP walking in the past. It's really no fun. Yang isn't, I'll hold my biases. Yang's okay. It's all right. I'll put it that way. But Yang's at least very human readable. So over to the left is the Yang model for OpenConfig interfaces. And you can see here, like this is pretty easy to read. They just really have key names. So like interfaces, interface, the name of it. The name of it would be Ethernet 1, Ethernet 2, Ethernet 3. Underneath it, you have a config portion, which has the name, type, MTU, description. We'll get into that a little more. Yang itself, it's really just a schema. So you'll hear the word Yang tossed around a lot. Like typically you hear it tossed around with like netconf. And I think the reason why that is because it was really one of the first transports to be around for OpenConfig, and just Yang in general was netconf itself back in like the early like 2000s-ish era. But Yang's interesting because it doesn't just work with network stuff. Like you could actually do it with Wi-Fi access points, which is like incredibly cool. Like if you go to the GitHub OpenConfig working group and go for models, like you'll find stuff for Wi-Fi, which is pretty interesting. But Yang itself, like I said, it's very human readable. At the very bottom, you can see leaf MTU, and we all know MTU is simply just an integer. So it's a 16-bit integer on line 378. And it gives you a little description of what it is, tells exactly what it is. And once again, it's kind of very human readable for the schema. Diving a little more in the interface model, you can see that things like bowls, so boolean is a thing. So under interface, you would see leaf enabled, like the default's true, so it's enabled, but you could see whether a device is enabled or disabled. The description is pretty obvious, like that's going to be a string. There are situations where you're going to get to Yang types. So in the bottom left-hand corner, we see in octets is of type OC Yang counter 64. And obviously that's not a typical type like string, integer, boolean, uint, so on and so forth. So you typically have to do what you're going to see with a lot of Yang models, or they import other models. Just kind of like a programming language. Like if they need access to libraries or packages or types, they have to import them. So as you go through and look around Yang models, you'll see things like this. Like for the OC Yang types, like you'll see here, import OpenConfig Yang types, prefix OC Yang. And these are all versioned through Get, as well as version through a little bit through here as well. You'll see a couple Yang versions. Once they hit a major version, it'll say like Yang version 2 and so on and so forth. Like I said, stop me if you have any questions. Feel free to unmute. However, look a little more at Yang OpenConfig models, which I'll describe what OpenConfig is here in a little bit. But there's a good way to visualize these things, like with something called PyYang. And PyYang is a Python program in which will allow you to visualize all of the Yang models. So for example, this OpenConfig interfaces, and it's even more human readable in my opinion. But when you go through these models, like in the schema, they'll have specific things that are kind of difficult to understand. Like for example, question mark. So a lot of times people ask me, what is the question mark within Yang? And it basically means it's optional. So as vendors create these models, or in OpenConfig there's models, you'll see a lot of question marks, and it basically means it's totally optional for the vendor to implement it. The other thing is the key name. So at the very first, at the top of it, you'll see interface, asterisk, and you'll see name. So effectively what a key name is it's going to be an array of things. So when I say an array of things, an array of interface, like name equals Ethernet 1, name equals Ethernet 2, so on and so forth. You're going to have a read-writable portion of a Yang model, and you have a read-only portion of a Yang model. Typically when it comes to config, well, always when it comes to config, it's read-writable. So the config portion is going to be what's actually configured on the switch. So whether, what name it is, what type it is, what the MTU is, all those things there enabled. All those things will be there. They shouldn't change unless a human being actually changes them. State tree is what you care about. So state tree is typically what you stream. So the state tree on the interface model, for example, you'll see things like name, type, MTU, and as you even go down, it has counters. And counters will be part of the demo. But in octets, and packets, and unicast packets, those are the things you really want to stream. Like those will be on there. And like I said before, this is all typed. So you can see next to enabled, it's a bool. You can see the description, it's a string. So typically just the way a schema would work. Don't worry about Yang. So Yang itself creates a Yang tree. You're going to see this all over the place as you kind of go through your journey on streaming telemetry. All these things about Yang trees, like what exactly they are. So the switch has to build effectively a database for Yang. And you'll see at the very to the left, you'll see it starts with slash. And you'll see these like little circles. and little circles go down, more circles, more circles, more circles. And effectively means like you're kind of drilling down the Yang tree. So the best example I can give is like network instances or interfaces are two common ones. So network instances will have everything from like MPLS to BGP to IS to OSPF, SR, TE. That's going to be there. You just drill down the Yang tree more and more and more. Interfaces, same thing. Interfaces, interface, and the key name. But you're effectively getting like a Yang tree as a database. Which is Yang like a JSON format. So JSON's more of an encapsulation or a data structure. Yeah, Chris, you can do that if you want to for name equal asterisk, depending on the way the vendor implemented it. But Yang is effectively the schema. So you can get JSON data out of this, you can get protobuf data out of this, but the way that JSON data actually looks in the schema it belongs to is what Yang says. So for example, you're going to render out some JSON, like potentially to configure this, or like even when you're streaming, so that when you do interfaces, I could like back it up here a little bit. Like when you actually stream this, you're going to see, for example, like name is always going to be a string. Description is always going to be a string. All these things have to work the way you would imagine to do. I missed that last message there, Chris. But back to this, the Yang tree. But effectively, you're just pulling out a database. Correct. Yeah, it's more like a yes, like a model-like definition. Agreed. It's a modeling schema is the best way to put it. OpenConfig standard model. We're going to get to those here in a little bit. The vendor extensions are pretty cool because like the vendor extensions allow vendors to put specific extensions they want to. So things that are not belonging to OpenConfig, for example, like we created a history extension. Trying to think of some other ones. There's a depth extension that there's a PR for currently. There's another extension that I'm really excited about, which is going to allow configuration sessions. So right now, if you configure with gNMI, there's no sort of Canada config. There's no sort of commit session. But right now in flight, there's a pull request to OpenConfig to allow a Canada config, basically. And I'm excited for that because some of the stuff, I know we're going off basis here, but like netconf is good because it allows all these RPCs. Like that's, and these RPCs allow Canada configs and such. Where gNMI is good because it allows streaming. Basically, that's the good transport about that. But going off on a little bit tangent here, my apologies. So that being said, what is OpenConfig? Let me blast through some of this here. OpenConfig is the dream of it is effectively taking Yang models and having them be the same across every network vendor. Like, so either vendor you have, it could be really anything, adopts OpenConfig models. And if you're talking to vendor A, B, C, D, J, N, whoever it is, they have those models on the switch and everything looks the same. And effectively, you're just talking to one API and you're streaming everything out. Like that's the ultimate dream. And it is kind of rough getting there, to be honest, with today. But kind of the tools that I'm going to bring up here have really made it a lot easier for people, I'd say, in the past couple of years to do that sort of thing. And also the ideology is that you would go to the OpenConfig GitHub, you go through their public models, and you can kind of look around and see what things are, which is great. And then if you want to like actually put a pull request in to add a new model, it's possible to do that, and vendors have to put that into their devices. It's pretty cool, but they're basically organizational, like vendor neutral data models is the best way I could describe it. But just imagine if every single vendor had the same API, had the same responses, paths, so on and so forth, that's what OpenConfig is. So in this, OpenConfig in general extends like beyond that. I just have a little bit of this on here because I feel like these projects are important, although we're talking about streaming telemetry here today, because all the data like for this to make OnDatch, KNE, OTG, gNMI, gRPC all work, the data structure they use is all for OpenConfig. So there's some really cool projects. I recommend everyone, if you're interested, like taking a look at this because it's a framework. Like OpenConfig is an entire framework. We could talk on and on about it. Maybe that's a future session. But all these things use OpenConfig in some way or another to configure devices or take streaming telemetry off of them as well and make some of these other projects work. All right. So there are other Yang models. Good. Is there a question? Good on here. There are other Yang models. So typically they begin with what they are, what group. So there's IETF, and they're all like, and they're all based on Yang. They're just a totally different schema. So IETF has their own versions of Yang models. OpenConfig has their own versions of Yang models. And then obviously I work for Arista, so I just brought up our vendor-driven models. And there's Yang models kind of like for different groups and so on and so forth. Typically when I talk to people, like the best thing to do is to stick as close as you can to OpenConfig models because that's going to be typically the same across all vendors. So if there was like, for example, this Arista experimental EOS EVPN actually got moved to the network instances model. So it's, kind of nullified at this point. But if you were to move to another vendor or you have other vendors in your environment, like that's not going to work on other vendors. That data structure, everything for it is not going to work. So typically what I tell people is stick with as much OpenConfig as you can, as much coverage as you can. It's way better now than it was a couple of years ago. But as much OpenConfig models as you can versus vendor is the best thing you can do if you're trying to make this thing work. Okay. So gNMI, what exactly it is. Like I said, it's just a gRPC service. Like it's really it. Like gRPC uses HTTP2 as a transport. Streaming is really king. Like that's really what you use this thing for. It could do other things like get, subscribe capabilities. We're going to walk through that. And all fields are auto-generated off of what's called a protobuf file. And you can read the protobuf file if you like to. The protobuf file is worth looking at just to kind of see all the capabilities of it. Even if like you're not used to protos, it's just something super fascinating, interesting to see. The specification, the gNMI specification is really good as well. So on the OpenConfig GitHub, I think there's a portion called reference, and you could go there and read the spec, kind of like how paths work, how different portions of gNMI work, like origin fields, and we'll kind of dive into that a little bit. But effectively, the way you turn this on, at least in the Arista use case, is a couple CLI commands make it work. Most of the stuff we're going to do in demo is going to be insecure as far as like not using a cert, but typically certs are used in production. All right. We'll talk about this a little bit, just talk about this a little more. But effectively with gNMI, with the service, you have the get method, and get gives you a path. Capabilities returns what the switch is capable of and what YAML models are on it. Set will configure, but we're not going to do much of that. All right. All the demos today we're going to do, so we'll go on a couple of demos that'll just do gNMI-C, respectively, just kind of look at the way things work with gNMI-C as a binary. And then we'll dive into gNMI-C with Grafana, Prometheus, and some other fun stuff with gNMI-C. But gNMI-C has really done like phenomenal work for like OpenConfig. Like, so OpenConfig owns gNMI-C at this point. It spun out of Nokia. The maintainers did really good work. I feel intrinsically that if gNMI-C was not around, I don't think a lot of people would be as knowledgeable as they are with gNMI and OpenConfig and so on and such, because it's really great. You can pretty much take this binary, get it from OpenConfig with a one-liner, OpenConfig GitHub with a one-liner and install it. And it's really, really simplistic. It's really, really nice, but it should be on everyone's radar to kind of mess around with. But effectively, like the gNMI-C binary just connects to the gNMI-C service or gNMI service on a switch, and you can kind of mess around with a lot of things from there. But gNMI-C, all you really do at the bottom, like at this most simplistic case, is -A is for address, -U is for username, -B is for password, and the method is going to be either get, set, subscribe. You also do delete or get, set, subscribe capabilities. Any additional flags, which might be something like a token, insecure, cert. There's a whole bunch of things. And also too, gNMI does not, you can make it to the point where you can do this with the cert and not require a password. But given that this is like demo and this is 101, we're going to do static username and password for all these. All right, capabilities. So I'm going to bounce around a lot back and forth from VS Code. So I think this should be within the meetup information. But this repo here, hopefully my screen is showing good. I'll make this a little bigger. This repo here, everything's kind of running in Container Lab, so we can see. So I have 3 COS nodes. I have console agent. We'll get to why these are there, why these are relevant. But effectively, I'm just going to run gNMI-C against these. All right. So the first thing we'll look at is like what capabilities look like. So let me pull up the README here. What are those? Container Lab, I'm not sure what you're referring to, Jack. Pipe itself less. So when you run this, you're doing -A, which is the address, username, and password. You're asking for capabilities. Remember, capabilities tells you what the switch is capable of. You're doing this insecurely. We could do a cert, but this is just kind of demo, so it's like, whatever. But effectively, like the device is telling us this. It's gNMI version 070. You can go back to the spec or the protobuf. It'll tell you what version it is. And I'll kind of tell you like all the models which are available. So if you're ever curious, like what is actually on a device, like what YAML models live there, capabilities tells you exactly that. So everything's kind of here, which is nice. At the very bottom, it'll tell you what encodings are available as well. Lots of models on it. I think I haven't seen a relay agent. Like, I never realized how many they really are. There are a lot. But at the bottom, you'll see sample or supported encodings. There's JSON, JSON IETF, and ASCII. Mostly people just do it off the JSON. I think that's the default if you read the spec. But the only thing that's not coming back to you in JSON format is going to be capabilities. The get method. So if you want to use get, it's like I said, it's a one-time shot of a kind of a path. So we're gonna pipe this out to, I'll call this everything. So get -s path, look at all the stuff. I'm gonna pipe this up to less. You can pipe it out to JQ if you want to do, but it's like, it's a lot. So you can see here, like this gives us everything. This is pretty much the entire Yang tree as a whole. So we can get pretty much anything you want to, like out of the device, which is like super cool. In the slides, to note, just bounce back and forth here. Where are we at? Like get, like here's a simplified version of this. You can see here like the path for the request. And all the path and the values are things you care about, like it's a repeated list. So path slash values. So OpenConfig interfaces. And this is the data model, like I said before, like that the question was asked about Yang. It kind of gives you the schema of what this is, config, MTU, name, all the config portion, or the state. Now, the part that is like most relevant, especially for like streaming, is the subscribe method. So we'll do the same thing here, but we'll do subscribe. Subscribe path, and what we'll do with subscribe is we're going to ask for this. And actually, I'll get to this here in a little bit. I don't need this OpenConfig colon, so if that's something we're questioning, don't exactly need that, and I'll explain here in a little bit. But I care about interface state counters, so we're going to stream those. And gNMI is streaming to this, like I said, like as quickly as I'm asking for it, is streaming it back to me, the client, which is pretty awesome stuff if this is like the first time you're seeing this. And like I said, the binary is like incredibly just easy to use, like if it's something that's brand new to you. Especially like it's kind of shocking how easy it is for an open source world to just kind of get this and make this work. But it is actually there. Is that shape flag? So it'd be correct. Yeah, so it's -A is for address. We'll go into EOS native paths as well. So very nice. A tutorial on that. EOS native paths are something that are interesting. So we talked about like vendor, what I like to call vendor Yang models. So the way you get the vendor Yang model is you have to do this thing called the origin portion. So basically what the origin is that by default, if you leave nothing else, so like this, like around a couple minutes ago, I had to get rid of OpenConfig colon. Basically, the switch knows that if you're not creating anything in the origin field, they call it, and I know it's kind of hard to explain, but basically, there's a piece of metadata in gRPC. Well, I'm sorry, not a piece of metadata. It's a part of the method for the subscribe or get request. It's which is called origin. And if you change up the origin and put it in the path name, it'll give you vendor specific models. So under EOS native, we have kernel proc CPU utilization total. So when I go for that, it'll actually give me like CPU proc information stuff, which is like kind of neat. One thing that's like, I don't know, I call it hack, because it's not a hack, but like for us, like we have this CLI origin, which a lot of people like it. You can't stream this, but you can do like any type of GET request with this. But most people who have Arista have kind of worked with eAPI. You can actually blast away show commands at the device through the gNMI interface, which is kind of cool. So as I type that in the origin, I'm getting a show version. So you can see here, I can key off all this stuff. And this should be applicable to gig which it is. So it's all valid JSON. So it's kind of cool stuff. Like all this stuff's in the repo. So I have like everything I did, even AFTs, which are one question I get asked about a lot, or these things called AFTs. I'm not gonna have too much on here, but like a lot of people think like, oh, streaming telemetry, I can stream the route table. You can. There's just some complexities to it. So they're called abstracted forwarding tables, I believe. They mainly give you next hops and they point to a value. A little bit hard to work with, but it's possible to stream this, and it's also possible to stream some of the BGP stuff with some other technology that's out there. All right, let's bump back into the slides here. Any questions? Like, because I'll talk and talk and talk. Okay. So, any questions? Feel free to interrupt, ask. Not a problem. I'm seeing the chats as they fly by. Try to answer them as best as I can. But walk through subscribe, how that works. Like I said, like the barrier to get started in this is like so simple. Like because back when I started a lot of this, like probably almost 8 years ago, like there was no gNMI. You were writing code, so it was a whole bunch of fun. So and OpenConfig has changed a lot. Like in that time, like there was not nearly as many models that were out there for it. But gNMI makes the barrier for entry like super easily, and anyone can really get this. Turn on gNMI with like your vendor choice and make it work. The origin field, I talked about this a little bit. Effectively, if the origin field is nil, being like there's nothing there, it'll default to OpenConfig. So when I ask up top here for interfaces, interface state, it's automatically going to use the OpenConfig interface UI model. If I ask for EOS native EOS image, I'm actually going to get what version of EOS I run because that uses the EOS native model. Hopefully that makes sense. Like, it's nice because you can get kind of everything out of this one interface, like with gNMI mostly, like with different vendor models. So it's pretty cool. Like, you're not doing this over REST, you're doing this over gRPC. Sometimes the vendor models, they stream, which is nice. But effectively, you can pull state out of whatever it is. This is another common question I get. Is this a pull? Is this a push? Kind of both, depending on the way you look at it, because you're streaming to the server and the server streaming back to you. So depending on however way you want to peel it there, could do both. As long as you're getting, like for the foundation of telemetry slide I had up there, as long as you're getting any change delta as it happens to fly over and stream, you're good. Like, at least in my opinion, but you have many different opinions on the way this works. Another question I get asked with is like, what if my things are behind NAT? Like, what do I do? So what if you have a, I don't know, a site, an offsite that's not a data center that you need to get gNMI information from? You have things where something like gNMI gateway, I think most people have heard of that. But recently, I said not too recently, I'd say probably in the past maybe 2 years or so, gRPC tunnel spec came out. And gRPC tunnel is pretty interesting because it allows you to do is to run what's called a gRPC tunnel from the switch to a collector. So this will be referred to as dial out. The switch dials out, where just regular gNMI, what we showed previously, is dial in. Now, the idea behind this is that every switch gets what's called a target ID, and it registers. There's a protobuf for this as well. Everything in OpenConfig basically gets a protobuf, which is nice because you can see how the service works and functions and everything else. But the whole idea is that streaming telemetry happens through a tunnel that initiates from the client, which is going to be the switch. gNMIC is awesome for another reason. We'll have a contrast and compare thing with that in Telegraph here in a little bit. But gNMIC is awesome because gNMIC actually has tunnel server. Like, they run this. So you can just take all your gRPC tunnel spec and just create a tunnel from the switch to gNMIC, and you get telemetry that way. So dial in or dial out is good. Mostly use cases I've ran into with most people that they want to use gRPC tunnel is specifically because either they're doing some kind of gRPC load balancing, which is kind of uncommon. The most common thing we see is NAT. So no publicly accessible IP or hostname. So the device has to actually dial out to a publicly accessible gNMI collector. So what is gNMIC to gNMI? I just took this slide from from the gNMIC maintainers, but I think I've talked a little bit about kind of what this is and what it is exactly. The command line's awesome. So the CLI, the binary, is really great. Like, you can kind of interrogate a device on what it's doing, how it's functioning. All basically be either OpenConfig, EA models, or just vendor stuff. Even CLI, like it's all kind of there, which is like really fascinating. And you can, and I've just showed it from the binaries perspective. You can have a YAML file, kind of have a bunch of things in there as well. So you have to type it out. The nice thing about gNMIC, well, there's many nice things about it, is like it has a concept of clustering, which we'll get into the gNMIC demo if you were to build this in production, like what that would look like. But effectively, you can take gNMIC and cluster it together. So you have like a three-core cluster. So if one of the gNMIC devices or pods or containers processes however you're running it, it does tend to break, go down for maintenance. You're still going to be functioning. Your observability is still there. And there's many more points, but the Go module for gNMIC is really good. Not just controls the device, but does some really interesting stuff with like creating the models, like the JSON for it. We're going to contrast a lot of gNMIC to Telegraph because, like I said, in my day job, I deal a lot with telemetry, whether it's like our Cloud Vision Portal platform, which is the enterprise platform, or whether it's open source stuff like TickStack or gNMIC. I deal with both, and this question's really tossed around with like a lot, which is what should I use? Should I use Influx or should I use Telegraph or should I use gNMIC? Hold my biases for later, how I contrast these two, but if you're unfamiliar with Telegraph, Telegraph's like a middleware thing. And effectively, it's a binary. It can run in a container, however you want to do it as a process. But what it does, it takes specific inputs. Now, back historically, the idea for Telegraph was you'd run it on a server, you'd collect all these memory, CPU, disk usages, kind of things about the device, and you'd ship it off to Influx. And you would historically just use Grafana to graph it. I mean, I think everyone has seen that. Most people have seen that life. But there's a rich amount of plugins for Telegraph, which are not just like CPU, proc, memory sort of thing. You can actually take in SNMP, you can take in gNMI, you can take in all sorts of things, syslog, disk, memory. It's actually pretty fascinating how many inputs it has. If you want to take those inputs, the data that comes in, and massage it a little bit, you create these things called processors. And then effectively outputs are where that data is going to permanently live persistently, whether that's in Elastic, Influx, or Prometheus. You can also do pub sub buses and such. The gNMI portion, to configure it, you'd have to actually put in every single one of your addresses as a target statically within a telegraph.conf file to make this function. Which leads me to like what most common setups are for Telegraph. Like there's a third one I'm not showing on here, I'll walk through that, but typically most people want Telegraph within their environment. They do one Telegraph for every X targets. So X targets typically would be like, I deploy EVPN in a fabric. I have a 8-way super spine followed by 4-way spines on like what we'll call like EVPN islands or EVPN fabrics. And basically what most people do is they'll have a Telegraph agent like per fabric. That's kind of common. The other one's a one-for-one Telegraph model. So if you had the whole process of bringing up a device, your process would also involve you bringing up a Telegraph agent to run externally. So externally it might be like Kubernetes, externally it might be Docker runtime, might be a process, so on and so forth. I've seen many different setups. The one I'm not showing here is that some people have asked for Telegraph on a switch, which we can do. I'm kind of iffy against that because once you change things, like it's got to be changed for everything, not like one central location. So if you want to do new paths, you want to do new certs, like it becomes really difficult to deal with once you get down to it. Open comparison of the two. So Telegraph is really easy to get started. Like most people get on Telegraph and they're like, oh wow, this is so simple, this is so easy. Because the truth is there's a lot of demos and a lot of different blog articles on Telegraph. It's the total everyone knows. It's plenty simplistic. And there are plenty of inputs and outputs. So usually with Telegraph, like you're gonna find things that are like for inputs of pub sub buses, inputs SNMP, all sorts of things. The outputs are really good as well. So outputs like Prometheus, also outputs like InfluxDB. And also too, like Telegraph does have enterprise support. It's owned by Influx, and Influx owns Grafana Cloud. So like a lot of people have Grafana Cloud. So it all depends on like what your use case is. Also, the plugins are super simplistic to write. They're all in Go. Plenty of really good helpers with it. But in general, like most people have some sort of Grafana Influx in their environment where this is already running, so I have to get ASO approval. That's typically what I see at least. And so it's just kind of a bolt-on to get rid of SNMP. Also, Telegraph does take SNMP in, so that is a plus for what it's worth. gNMIC is really awesome because it has distributed clustering of gNMIC. So like instead of having one Telegraph agent, if you have one for one or one for X, a Telegraph agent needs to be reloaded, needs to get restarted. It doesn't support hot reloads, which is kind of a problem. But if you lose one of the agents, like you lose all your observability, which is obviously not a fun thing. gNMIC has like really good gNMI features. So as gNMI features come out in OpenConfig, it's more or less like you kind of see them being pushed into gNMIC at the same time. Like it's super tied into gNMI just because of everything OpenConfig. The REST API for this is like really simplistic. I have it within my demo, but like it's very easy to use. The Go module is awesome if you're into Go. Like I'm very much a Gopher person. So the Go module allows you to control this dynamically, which is like really cool. The processors are interesting. So with processors, a lot of times like you'll find the data doesn't come out the way you expect the data to look like the stream data, like in my little, funsy demo lab, like look fine, you're like, I have some JSON, it looks good, but it might not be the way you want it to be. So you can key off of stuff as it comes in and then kind of like transform it with these processors and set them on their way. The loaders are awesome. So the loaders allow you to effectively load targets. So think of it like you're bringing up gNMIC. How do I configure it to have all my targets from all my netbox devices or all my Nautabot devices in my inventory? I want this to dynamically load inventory from somewhere. The loaders do that for you. So my demo, I grab it from a file, but you can kind of do it anywhere. The dial-up capability is really good with gRPC tunnels. There's plenty of other inputs, outputs I'm kind of glossing over, like NATs. The last part about this is like really it's community driven. So like if you want to, you file an issue, ask for a feature. Typically the maintainers get around to it. Like that's like really good. And just lastly, and then in Telegraph for the most part, like you can run this as a binary, so well, Telegraph sort of, or a container or a process. Now, within the demo, I've blogged about this week. If anyone got a chance to take a look at this, because I think it's like really awesome, and I've suggested to other customers too, like because it's really crazy. Like this actually exists. You could do this just as a free open source project, and you can almost have like not almost people are doing this, but running a production telemetry environment and just making it work, like which is really awesome with really easy barrier to get into it. So off to the left, you'll have your leaf spine network. It might really be anything. And you have gNMIC Quorum cluster kind of talking to all the different targets. You have Prometheus, which effectively scrapes gNMIC. So gNMIC has the availability to create what's called exporter. So they'll export everything they have into a Prometheus exporter. And I'll kind of explain it if no one's seen that. That's certainly new to you. I'll do my best to explain how that works. And then basically visualize all this with Grafana. And I just have dashboards that are pretty static setup for this demo. This is what the demo looks like. So at its easiest part to understand, you have gNMIC in the middle, and they're all clustered together. The way they discover each other is through console. If you're unfamiliar with console, console is more or less like what they call a service discovery. It's made by HashiCorp, excuse me. And the ideology is that an application talks to console and says, how do I find my other core members? How do I register for new services? How do I get key value pairs for the backend? That's kind of what console does. And console is also sort of free and open source. I have a paid version of it, but it's all via HashiCorp. Like I said, gNMIC offers a REST API. And the REST API like really easy to use. Like you can go to the documentation, take a look at it, and see what it allows you to do. But it allows you to dynamically and programmatically add new devices, add new paths, remove paths, modify things. That's really awesome because typically you don't get that with Influx and Telegram. So the whole ideology here is that you have an API to control everything. So whether, and one thing I was thinking about too is demo-wise, I didn't really get around to it, but you could have something like Netbox or Nautabot, specifically Netbox, with tasks, kind of send out like a webhook every time you create a new device, and that webhook could talk to the API. And as long as it's in the structured API to add a new target, you'll just get automatic telemetry. Like stuff like that's really neat. And the fact that you just pick it up and do it with this is like pretty incredible. All right, so that being said, let me pop over to the demo. Ask away any questions you have as we're getting set up here. But this thing's running a container lab. I think most of us know what container lab is. Container lab allows you to bring up network topologies as well as like other services, all with a container lab. So I ran this beforehand just to collect some data. We have 3 EOS containers running. So they run first the EOS and container. All the configs are within the config directory, gave them static IPs, so all within there. I'm only registering 2 and 3, 1 and 2 with gNMIC as a whole. Once I get down to the gNMIC portion, we have 3 quorum cluster, like I said. It mounts the gNMIC YAML file, and it mounts this target config file. And I'll quickly explain the way this works. The gNMIC YAML file effectively does this. It has, for every target, username and password. Before I was using the binary, but you could point this to a YAML file within gNMIC and it loads the YAML file. Because we're not using assert, we're doing this to insecurely. We enable the API server, which just looks like this on port 7890. And the loaders are really neat. Like I just kind of, I don't want to say I cheated. I didn't really cheat. I didn't exactly cheat, but like basically you create these loaders. This is the type file. There are other methods of doing it, like you could talk to a RESTful API endpoint. It'll dynamically load the targets. So targets config is right here. I basically just have those two devices. Pretty simplistic, pretty easy. Once you go down, the complicated part kind of gets into it. So like what subscriptions I have. So interface state counters. I want to see the BGP config portion, and I want to get like the memory info out of kernel. The clustering as a whole, the way this works is that I'm going to call this cluster name cluster. I'm going to use console as service discovery, and I have a console agent running as well that this talks to talk to console, which I'll show. Lastly, every single one of these takes a Prometheus exporter. So every single Docker container which runs gNMI will actually export its metrics. So if you're unfamiliar with this, I'll kind of show it. It'll make a little bit more sense to you. But yeah, that's kind of the infrastructure as a whole. Just quickly taking a look at the way console works, which is this. So this is the console service. Every single gNMI device talks to this, and they cluster themselves. So you can see gNMI API 1, 2, and 3, all within there. And they form what's called a key value backing. So gNMI cluster, and we see our targets. They're all within there. So that's how you cluster. That's how it knows. And lastly, within the service discovery realm of things, Prometheus is here as well. So Prometheus itself can script console, or can do it statically the way I did it. But effectively, Prometheus knows that, hey, like I can scrape this dynamically and find my devices. Prometheus. So Prometheus it's beyond the scope of this talk of kind of like the way Prometheus works, but the whole ideology is that you have so using console instead of a group environment. Correct, yeah. So console makes it more dynamic. So if you added like gNMI 3, 4, 5, 6, 7, it will be able to find them automatically and cluster if they figure out it later. Prometheus as a whole, the ideology is a time series database. It allows this really cool thing called PromQL, which is a query language. And what it does, it scrapes environments. So I'll go to my targets, and targets are the actual device on port 9804. And this should have some data here, like saying what it is. So I'm trying to make this a little bigger. But effectively, gNMI 1, it exports all these, what I think the exact terminology is called labels. But basically, it's just like a little website that you put out, I'll call it a website, but you put out endpoints. And effectively, Prometheus itself just does a REST call and gets this data every so often. So it's there presented to you. So if you think about it, the way this works is you have 3-core cluster that exposes little websites. Prometheus itself goes, gets the data, and puts it back in its time series database. It will then allow you to but query things like interface state counters. Let's see if anything shows up in multicast packets. We've got some stuff. You can see here like the .2 and .3 set out some multicast packets over time. Let's see what else I'm going to grab. I'll probably get nothing for that, which I don't because it's some demo lab. We can go in and see things like in.pet packets, which probably should get some data. You could do this over time. You could do it through rate the last 5 minutes, but that's pretty much how Prometheus works. Like it has a database. You use PromQL to pull out data, like rate. I don't know if it's going to work or not. I don't think it will because I very much forget. But I did. So the rate of the last 5 minutes average. It's terribly bad numbers. But this PromQL language is actually pretty easy to work with. You can graph it inside here, but that's kind of Prometheus as a whole, the way it works. And then typically what you do is you pop over to something like Grafana. And I've had this thing running for some time, for the past like 20 or 30 minutes here. But you go into a dashboard like this, and let's go over to the last 3 hours. Stupid Chrome thing. Hold on. Yeah, go for the last 3 hours. We can see here all this data. So like, and this is basically just talking to Prometheus and asking it for query stuff. So you can see here at the very bottom, Usually what you can do is you can copy and paste this into Prometheus, and typically it works, hopefully. Oh, got nothing. Usually it works, but you know, demo gods are against me here. But yeah, effectively, and oh, this is for the past 3 hours. But effectively, yeah, you can grab things, and that's how it talks to Prometheus. Like it is through Grafana, and these are really set up just for this lab environment. Like that's pretty much it. I see we're almost up on the hour here, so I'll try to speed through this. But yeah, if you wanted to run this lab yourself, it's very simplistic, up and running. Like all the READMEs here kind of tells you how to get through it. The last thing I'll show is the API. The API is extremely powerful. You can either use what I have, which is going to be a Go built binary, which is in here. If anyone's really curious, kind of take a look at it. Just kind of like proves a point. But I'll just use curl. Just use curl. Got to find the leader here. Give me 1 second. Because the way the clustering works, which are gNMI C3. But effectively, like to get all the targets through this, which I should right now only have 2 of them, I can announce the API for all my targets. It gives me my targets, so you can see here .2 and .3. They show up. You can see all the information about them as well. If you wanted to get the subscriptions, same thing, very easy to get all the subscriptions, which this will tell you that. Just pop over here to my C3. It show you my interface counters, my BGP portion, my memory proc info. And then the really cool part, like this is the part where I'm like always like, this is awesome, this is great, is the actual adding of devices. So if we wanted to, we could just add a device if you know, by all means. So we can add .4, we add the address for it, username, password, but you're basically adding this device to it. I'll just curl POTUS that and the gNMI C3. So if I go back and I look at the targets, I should see 1 more. So just absolutely awesome in my opinion, because you can add stuff and you can also delete it too. So I'll start to get telemetry data for .4. I'm not statically putting it in, I'm doing it via the REST API, and then if I want to delete it, you know, it's hopefully gone. Yeah, that's why. All right, and at this point, .4 should be gone. So get targets, only 2 and 3. So in my opinion, this is incredibly awesome. Like in all this kind of demo work I have there, like you can go with that. If Go is your thing, you can build a binary. The URL of the repo, it should be in here, but it's this right here. I'm gonna take a look at this. So github.com/brandyd, and you'll find Telemetry Meetup 2024. If you look at that tab. But yeah, as long as you have Container Lab and a couple other things, it should just work out for you. And the last thing I'll leave you here with is like, there are some pitfalls. Like I'm in demo land, like I'm showing this, it looks great. And it truly is. Like I think it should be on everyone's radar. But Yang is extremely difficult. Extremely difficult. At the Network Automation Forum, like Rob Shakir from Google went up and talked about a lot of this and said Yang might have been a mistake. Maybe, maybe not. Like Yang is really hard to work with. I wish we had some form of JSON schema or something else, but this is honestly the best we have. And there's a vendor API, I'm sorry, OpenConfig API that goes across everything with gNMI. So it's very good. Not everything has coverage. That's the other problem you're going to hit with this. So SNMP might have to stay a little bit longer. Like my opinion is that you should try to stream anything and everything you can, and then some push-based stuff or SNMP-based stuff will just have to stay. Not every OpenConfig model is supported, so typically you're going to have to use these vendor models. And the problem with the vendor models are pretty obvious. So if you have stuff that works with vendor A, it's not going to work with vendor B and vendor C, and vice versa. Augmentation and deviations are things I haven't talked about much, but augmentations and deviations are basically, I take a look at this Yang model, it says it should be this, but it deviates just a slight amount. Like it doesn't have this or doesn't support that. Augmentations and deviations are something that is a little bit frustrating, but at least it's in the Yang models, it tells you what it's capable of or not capable of. Upgrades and tolling. So as you typically upgrade these things, like the switch devices, you're going to have to upgrade your tolling as well. Take advantage of the Yang models. Vendor support, like I said, not everything's supported. Not everything has gNMI within the tolling. Finding paths can be kind of cumbersome with the vendor-based Yang models. And then just lastly, like with new models, typically requires new upgrades. And when I say that, you might be running something like, some example from the top of my head was some of the So, but yeah, yes, I know exactly what that is without even clicking on that link, which is funny. The meme with yeah. Anyway, typically new models is the same or greater, same or is equal to new switch code. So effectively what that means is like you might have a DCI, which is like incredibly stable. And your DCI is running MPLS, and let's say you had some sort of SRTE feature you want to stream, but your version of code is a couple years old. To get that, you might have to upgrade to a newer version of code that supports SRTE Yang model XYZ. So it's a couple of pitfalls, but I mean, in all honesty, like you can replace a lot of SNMP today with gNMI or Telegraph, like, and stream it and not have to worry about constant pulls. So with that, I'll open the floor up to Q&A. It's kind of what I had there. If there's any questions, I know we're a couple minutes over. When running a multi-vendor where you can't use OpenConfig, is there a good way to map? Let me go at the bottom here. It's a little bit weird on my screen. Is there a way to map vendor models into an agnostic model? There are people who have tried this sort of thing. It's kind of rough. Like the way most people do it is like they take vendor models and they use things like processors to make them look the way they want it to look. Like almost like another abstraction based. Yeah, Starlark works really good too. Like Starlark is very Python-esque looking. Like it basically makes it look like you take this data into a function and then you can return it in different formats. It's not going to make much sense me talking about it, but Starlark is available for both Influx, like Telegraph, and it's also available for the Go Starlark version as well for gNMI.
All right. Any other questions out there? Anything anybody wants to come off of mute for? All right.
Thanks, Daniel.
Yeah, great presentation. I think topic-wise, the repos, everything you've got posted are awesome. For everybody that's out there, I will take this recording. I will get this posted with the links and everything up as soon as possible. And so usually within a day, I'll have everything published and available on the community with everything that you'd need from the call today. And then for everybody else, we do have another meetup scheduled. I believe it's April 24th. It is going to be Jeff Doyle from Juniper is presenting on Abstra. So that's the next session. And then we're going to, we try to meet every 4 to 6 weeks. So please stay tuned to what's posted on meetup.com and on the community as well. And with that, we'll let everybody go. Daniel, thanks again. It was awesome. Looking forward to this, and everybody have a great day.
Thank you.
Thanks, everyone.